Okay, everybody, let's go back to the unit circle. Okay, so I put a bunch of new information on the unit circle, so I'll back you up. So the unit circle can be on a graph, but the problem is when you put the unit circle on a graph and it has a radius of 1, it's really like this big on graph paper. So we know that as far as coordinates, you got to point at 1, 0, 0, 1, you've got to point at -1, 0, and you got to point at 0 and -1, but then all of these other angles are never going to fit. So that's why we made the unit circle nice and big. Now we still have all these special angles. So these special angles touch the circle on its circumference, and those special angles would, touch the graph in all these different spots. So they'd all have coordinates too. So how do we find the coordinates of all of these points that come from this angle? Well, first of all, we know that we can get the easy ones. The coordinate point here is 1, 0, 0, 1, -1, 0, and of course it's 0, -1. The other points, though, we have to go and look at special right triangles. So the first special right triangle I want to look at is the 45, 45, 90. Okay, and the 45, 45, 90 triangle, do this on a separate sheet of paper. If you drew a 45, 45, 90 triangle, we know that it is half a square, right? 45, 45, and the radius is 1. Well, if that occurs, then from our special triangles that we learned in geometry, this side is the square root of 2 over 2, and this side is also the square root of 2 over 2. So any point on the circle would have an x and a y value of square root of 2 over 2, square root of 2 over 2, x, y. So our coordinate would be square root of 2 over 2, comma, square root of 2 over 2, which we have here for our 45, 45, 90 triangle. Now we've got another 45, 45, 90 triangle here, except it's got a negative x. We got another 45, 45, 90 triangle here, except it has negative x and a negative y. And we have a fourth 45, 45, 90 triangle right here, but it would have a positive x and a negative y, okay? So what about the other triangles? We also have, as far as special right triangles, we also have a 60, 30, 90 triangle with a radius of 1. And we learned in geometry, if that's the case, from our special right triangles, that this side is 1/2, and this side would be 1/2 square root of 3, or square root of 3 over 2. And again, if I need this coordinate, it's going to be over and up, so we get a coordinate of 1/2 square root of 3 over 2, and we put those in my unit circle too. So here's my 60-degree angle, here's my coordinate 1/2 square root of 3 over 2. We have another one over here, except for it's got to have a negative x value. We have another 60-degree angle down here. They're both negative, -1/2, negative square root of 3 over 2. We have another one down here in quadrant 4, but it'd be a positive 1/2, negative square root of 3 over 2. Now, the exact same triangle on the 30-degree angle could be this triangle, but just laying on its side. So you could have a 30 degrees here, 90 here. Radius is 1, so this side's 1/2, and this side is going to be square root of 3 over 2. So the coordinate of this point would be square root of 3 over 2 and 1/2. Okay, again, we put all of those triangles into our circle to get all of the coordinates along the circle, okay? Now, how does that help us? Well, what we've learned, let me go to our notes, is we've learned some things about sine and cosine. Now, we know that if the circle has triangles in it, then we can use right triangle trig. So we're going to use the unit circle to evaluate trig ratios from special right triangles. Now here's what we know. We know that sine is opposite over the hypotenuse. But since the opposite is the y value and the hypotenuse is 1, it's just the y value. So wait a minute. That means the sine of 30 degrees is 1/2. It is. The sine of 60 degrees is the square root of 3 over 2. It's just the y value. The sine of 5 pi 6 is 1/2. It's just the y values. Okay? Same thing with cosine. Cosine is the adjacent over the hypotenuse, which is the x value over 1, which is just the x value of my unit circle. Okay? So I could say, what's the cosine of 330 degrees? It is square root of 3 over 2. What's the cosine of 240 degrees? It's the x value, which is -1/2. Okay, so we can do all of these from the unit circle. Okay, so then we know tangents y over x, so we can evaluate all these. Sine of 90, we go to 90 degrees, it's the y value, 1. Cosine of 90, we go to 90 degrees. Cosine is the x value, it's 0. Tangent, though, at 90 is the y value over the x value. So into tangent 90, it's the y value over the x value. You get 1 over 0. Wait a minute, you can't divide by 0. So it's undefined for tangent at 90 degrees. Sine of pi, okay, go to pi, it's the y value, 0. Cosine of 2 pi is going all around the circle twice. 2 pi cosine is the x value, it's 1. Tangent of pi, it's the y over the x, so it's 0 over 1, which is 0. Sine of negative pi halves, well, if that's pi halves, then negative pi halves is just the opposite rotation. And if I want the sine of that, it's the y value, which is negative 1. Tangent of negative 3 pi halves, let's see. Let's go negative 1 pi, 2 pi, negative 3 pi puts me right here. Tangent's the y over the x, it's 0 over negative 1, which is 0. Okay, so far so good. The unit circle is awesome. Okay, turn the page. Now to ask a question. When is sine positive? Sine's the y value. It's positive in quadrants 1 and 2. When is cosine negative? Well, cosine is the x values, and it is negative in quadrant 2 and in quadrant 3. Okay, good. Now, this is a different question. It says find an angle that has an x value of negative 1. Find an angle that has an x value of negative 1. So an x value of negative 1 is right here. The angle is either 180 degrees or pi. Depends on how you want to call it, degree or radians. Okay, this says give me a tangent value of 0, okay? Well, tangent value of 0 is right here because that's the 0 over 1, which is 0. It's also here at 180 degrees, okay? Sine, give me an angle with a y value of negative 2. We said it's impossible because it's the unit circle. The farthest end goes negative 1. You go to negative 2 and it's off the circle, so it's impossible, okay? Finally, number 4, we're not on the unit circle. How do I know I'm not on the unit circle? Because these values are much bigger than 1. So I don't have a radius of 1. So what is the radius? Okay, so I know that I can use Pythagoras' theorem, a squared plus b squared equals c squared, or better yet, x squared plus y squared equals r squared. That is the same thing as Pythagoras' theorem. So I went my x squared plus my y squared equals my r squared, and r turned out to be 5. So I know my x value, I know my y value, I know my radius, and then I want sine. Well, sine is the y over the r. Okay, I know that from over here. So sine is the y value of the r. So the y value is 4, and the radius is 5/4. Cosine is the x over the r, and I know that because over here it says x over r. The x value is negative 3, my radius is 5. Okay, that's all I have for today. There's the homework for you. It should be pretty easy.